all these scheduling algorithms or different types of processes, they figure it out like, okay, what we can do is we can classify different types of processes. And these processes, what we are going to do, we are going to put it in different what your queues, right? So like if we are going to create system process, so we will put it in this particular queue. If we are getting interactive process, we will put it here. If we are getting batch process, we are putting it here. So it's up to you based on different varieties. So I'm not saying that we can have only 3 queues. We can also make 10, 12, 15. It's up to us how many queues we can create. But yeah, it's up to you how many classes you want to create, right? Like that. So this is how basically you can see here that we have created different and we have used these different queues. Earlier, we are working on a single queue. Now it's up to you which algorithm you want to apply in this particular queue. If I want to apply SJF, that is shortest job first, in my ready Q1, so I can apply it. Because these 3 queues are not at all related to each other. They are not at all dependent on each other, right? With respect to your scheduling algorithm. You want to select, you just apply this scheduling algorithm here. You can apply round robin scheduling algorithm for interactive, because after going for further studies, they figure it out like, okay, for system processes, SGF works better. For ready queue, interactive processes, round robin. But if we have a single queue, so how can we apply that, right? And suppose you already know that we always give higher priority to system processes, but over there we won't be able to do that. All right. So if we are using round robin, so how can we do that? How can we perform? How can we give this particular priority and all? So that is why they have proposed multi-level queue scheduling algorithm. I hope now the basic idea about this particular algorithm is clear to you. That here, instead of using a single queue, we are using multiple queues. And in those multiple queues, we can apply different scheduling algorithm based on our, you can say that efficiency of performance. Suppose for system processes, SJF works best, so we will use that. Suppose for round robin, interactive process, round robin works best, so we will use that. Suppose for batch processes, FCFS, so we will use that, right? So this must be our criteria of selecting a process over there. Now, the thing again, I hope that if you have understand this entire concept of scheduling, so you might have one question, all right? So that question must be that, sir, that is okay. We have a, you can say that RQ1. I'm just writing RQ1, right? That is ready Q1. That is ready Q2. That is ready Q3. We understand this concept, sir, that okay, in all these queue we are having processes like, for example, these processes like that. We have understood this concept so far. That is okay. Like here, suppose we can apply different. That is okay. But from the beginning, you told us that, okay, sir, we have only single CPU. Single CPU means we have a single processor CPU. It means the CPU can execute only one process at a time. Only one process at a time. But from all these queues, we will get P1 from this, P2 from this, P3 from this. So now, how can we execute all these processes parallelly? All right. How we are going to execute all these processes parallelly, but we have only one. So is there any other selecting criteria? So the answer is yes. After this particular queue, again, we have a selecting criteria, and that over there, the selecting criteria which we are using it over there is your priority. Now the thing is, sir, are we using some priority numbers for that, or are we using some giving some different priorities? How we are assigning priorities over there? So in the case of this multi-level queue scheduling algorithm, what we are doing is whenever we are going to create these queues now, so after that we always set some priority for this entire queue. So remember that even in our real time, in our real world applications also, and whenever we are whenever we are accessing our operating system or any application, so you already know that we always give the higher priority to system process. So that is why system processes are having the highest priority. So that is why first of all, every time P1 process will execute, then we will give the next higher priority to interactive process, then P2 process will execute, then P3 process will execute. So in that particular scenario, in this manner, basically we execute our processes, right? Like that. So I hope now this concept is clear to you. Like in multi-level queue scheduling algorithm, we are using multiple queues. We are segregating all our processes in different queues, right? And we can apply different scheduling algorithm. But for again, after, because from this ready queue, let's assume based on that particular algorithm, we are picking up P1 process. Here we are picking up P2 process, P3. So now after that, out of these three processes, which process will execute first? Now based on the priority, right? So here we always give the higher priority to P1. Sorry, your system process, right? So this is how basically you can see that interleaved scheduling is required, and the issue over here is starvation. Now, from the beginning, we are studying the concept of starvation. Starvation means the process is waiting for an indefinite amount of time, right? Now the thing is, sir, are we getting the same issue here? I will say that yes, we are getting the same issue here. Then some of you, those who have already an idea about that, they will say, sir, yes, sir, it might be possible. We might get a starvation issue because we are using SJF over here. And in SJF, you are getting what? You can say that starvation. Even in FCFS, we are getting starvation. So, sir, that is why you are saying that we are getting starvation problem. No, what I mean to say is that you already know that in round robin, we never get a starvation problem, even though if we are going to use round robin in all these three queues, still we are going to get a starvation problem in our multi-level queue scheduling algorithm. Now again, the question is, sir, how can we get, because in round robin, we are never getting any, you can say that starvation issue. So how we are getting that? So just because of this point, as I told you about priorities. So for that, let's take a realistic example so that you will be able to understand. So you want to access an ATM, right? So ATM, remember, it's our CPU, right? Persons, P1, P2 persons are what? Our processes, right? So you can also map it like that. So in our earlier case, what we are doing in our FCFS, like in our ATM machine, we generally follow what? Your FCFS, right? So the one which come first gets the service of ATM, can execute his or her instruction. Suppose if we are using SJF, so what we will do? First, if all the process arrived, and let's assume that this P5 will take suppose 1 second of time to access this particular ATM machine, right? Then what will happen? It will execute it. But right now, in the case of multi-level queue scheduling algorithm, what we have done is we have created three lines. First one is VVIP. Let us take an example. Second one is VIP, and third one is common man line. All right. So you already know that in most of the instances, right, whenever you are visiting some temples or whenever you are suppose accessing some areas, right, some of the areas like some of the, you can say that, think about it like some museums. So they have some separate entries, right? You always stand up in a queue, and those who are having VVIP pass or VIP pass, they directly access that particular system. So in a similar measure, fashion, what they have done is, in the case of multi-level queue scheduling algorithm, they have created three queues. Let us assume this one is our system, this one is for interactive process, this one common man is, let's assume it as your batch process. So you already know that we will have P1, P2, P3 here, three persons. They are also standing in a queue based on the VIP also, because they are having the same priority, but still they have to, because only ATM we can, no two person can swipe their card in that particular ATM machine, right? Like that. And we have a P5 over there. Let's assume P4, P5, and here we have P6, right? Like this. So one thing which you can notice over there, when this P6 turn will come, first P1 will execute. You automatically know, right? Even though P6 is ready, right, to directly go, because he is the first one who can directly access this particular ATM, but still, because VVIP is having the higher priority, so first P1, then P2, then P3, then P4, then P5, all these processes, the person will swipe their card, they will, whatever the transaction they want to perform, they will do it, then only P6 turn will come. That is for sure. All right. So I hope this concept is clear to you. Now, why I am saying that here we will get the issue of starvation, right? So let's take one scenario. So we have P1, P2, P3, P4, P5, and all of them are standing in a queue. So now first P1 go there, swipe their card. So P1 task is complete, terminated. Then P2 person terminated. Then P3. So now my VVIP queue is empty, right? Now my VVIP queue is empty. So automatically now VIP queue will started the chance, get the chance to perform. Now the start the queue. Then P4 will perform the transaction. P4 will. Then P5 will come. Now, then before, just after P5, once this P5 gets completed, and before there is a chance of that P6 will come, suddenly at that time P7 process come here in the VIP. Then what will happen? Automatically this common man P6 will wait, because P7 and P8 will have a higher priority. So again P7 will go, then P8. Then again PVIP will come, P9 will come, or P10, P11 will come. So you can say that there might be a chances. I'm not saying that every time this will be the scenario, but yeah, we always think about it worst case scenario. Then you can see that this P6 is waiting for an indefinite waiting time. So waiting time is very high for P6. Still, you can see that P6 is the first person, right, who is standing in this particular queue. Still, this P6 is not getting his or her own chance. So that is the problem with multi-level queue scheduling algorithm. That is why we generally call it as that we are getting stuck in the problem of starvation. All right. So you can see directly that we can categorize our queues, right? If you want to categorize like system processes, interactive, right? All these are processes and they are based on the priorities. So first of all, if whenever any process comes here, we will give the highest priority to that particular process. So just because of this priority, this particular process or this particular process won't be able to execute, because every time you can see that these three processes keeps on coming and coming and coming, right? Even though they gets empty and they once they executing, and after that once they gets completed, let's assume again this process gets this queue gets some processes over there. So they will never get a chance, right? I'm not saying that they will never ever get a chance, but there is a very large waiting time for these two processes, right? That is an indefinite time. They don't know about when their chance will come, right? So this is nothing but we call it as your starvation problem in your multi-level queue scheduling problem. So I hope now this concept of multi-level queue scheduling algorithm is clear to you, that we first of all categorizing it into different queues. That concept is really good, right? We really love this particular idea that yes, sir, they have created these three queues, and based on that, they are applying different scheduling algorithm based on their performances. So that's why that is correct. But the issue is that, sir, on the basis of priority, we are selecting a process, and just because of that, we are never able to execute the processes those who are in the least priority queue, least priority queue, right? Like that. Now the question is, sir, okay, now we understand that. So that is why in our modern operating system, we never use multi-level queue scheduling algorithm. Now the question is, sir, if we are not using this particular algorithm, then what is the solution for that? What is the solution for that? So the solution for this particular scheduling algorithm is multi-level feedback queue scheduling algorithm. All right. So using this particular scheduling algorithm, what we are doing is we are removing the problem of starvation, right? So here in multi-level feedback queue scheduling algorithm, we have no starvation, right? Now, now the question is how they have removed this particular starvation problem from this particular multi-level feedback queue scheduling algorithm. Now we have understand that concept that okay, we are going for multiple queues and over there we are getting that particular issue, but how they have basically sort out this particular problem? So the answer is just because of this particular topic, keyword feedback. And this feedback is very important, right? Now I will explain you again with the help of same example, and I'm 100% sure that if you are able to understand that particular concept, you will never make any mistake while solving the problems of multi-level feedback queue scheduling. Now, here in this case, you can see that what are the parameters that are there is number of queues. So they have actually updated, right? It's not like that entire concept of multi-level queue scheduling algorithm is like we are not going to use it, right? It's just a waste. No, it's not a waste. This concept is not a waste because in this particular multi-level feedback queue scheduling problem, we are utilizing this particular concept of number of queues, right? We are using the same queue. And the second also the scheduling algorithm for each queue. So we can have different scheduling algorithm for different queues too, because these are the pros of that particular advantage of that particular multi-level queue scheduling algorithm. But in the disadvantage part of that particular starvation, how we are solving it on the basis of feedback. So what feedback, sir? Can you please tell me what this feedback is? Because most of you are having the same questions in your mind. So in feedback and using this feedback, what we are doing is we are either upgrading a process or either we are demoting a process. Now, still, some of you have an idea about, okay, sir, we understand about like, okay, in multi-level feedback, we are using the same concept, but now we have just added one new concept of feedback, and using this feedback, upgrade and demote is happening or occurring. But still, sir, we are not able to understand what actually how this multi-level feedback queue scheduling algorithm is gonna work. All right. So let's take again one example, the same realistic example I am taking, right? So then I'm going to tell you about the technicality about this particular algorithm. So we have an ATM machine. You already know about that. This is what my ATM or CPU. All right. If you want to map it with CPU, you can map it like that. And here we have VVIP, we have VIP, and we have what? Third one is our ordinary, or you can say that common man. Like, so we have P1, P2, P3, we have P4, P5, and we have P6. So this guy is standing first in this particular queue. Remember, these three queues are there in order to access this particular ATM. So what will happen? Which process will execute first? All of you will give me the answer. P1 person will get the first priority, then P2, then P3, right? Then P4, then P5, right? Then P6, right? So all these processes will what? They will get the chance. First P1, then P2, then P3, then P4, then P5, then P6. So that is the best case, right? So that is again we are doing it in the case of multi-level queue scheduling algorithm. But the issue was whenever we are executing it, let's assume after first P1, then P2, let's assume P3, P4, make it as P3, P4, and P5, right? Let's assume. You can change it. So what happened? Let's assume first of all we executed this one, and again P7 will work. So what will happen? Now we will execute P7 first. Now let's assume at that time P8 will come. So P8 will execute, then P1. So you can see that this P6 is waiting for a longer period of time. So how we have sorted out this issue, I'm going to tell you about that. So we have a P1 process, P2 process, P3 process, P4 process, P5 process, and P6 process. So what we are doing in this particular case is we are using the concept of round robin, right? Now in round robin, what we are doing is we have a time quantum, right? So we will check it this time quantum for all these queues. And once this time quantum, so it means that based on the time quantum, let's assume P6 should get a chance. But right now, P1 is executing. Right now, P1 is executing. Right. So what this P6 will do, what we will do with P6 is we will promote. Because now we won't be able to execute P6. Why? Because P6 is in the lower priority and we also have higher priority processes, right? You can say that queue processes, ready queue processes. So that's why what we can do is, because this process will never get a chance, so it's better what we can do is we can promote P6 here. So now P6, this will become a VIP process, right? Even though the functionality of process will remain same, but now we have moved this common man into VIP queue, right? In this particular queue. So automatically P2 will execute, then P3 will execute. Similarly, we can also move some of the processes from P4 to either to that particular side, and that is how we are going to execute all of the processes. So one thing which you can notice over there is that even if we are getting in future some VIP like P7, so automatically this P6 will after some time will move over there. So it will go to VVIP. If this common man process is not getting a chance, then automatically it will move after some time and it will go into the VIP. And once it will go to the VVIP queue, so surely there is a 100% probability that 100% chance that it will basically get the chance to access this ATM. So this is how basically this particular entire system or algorithm works. So you can see here that we have three processes. Let's assume this is your system processes. This is my interactive processes. This is my batch processes, right? So as you already know that if we have, right, so you already think about it like this also. So first of all, what will happen? If any process P1 will come, so what will they will do? It will go here. P2 will P2 wants to insert, so P2 will go to, and remember that P1 and P2 are what my system processes. Then let us assume if there are some interactive process P3, so it will go in the queue of interactive process. If we have a batch process P4, so P4 will go over there, right? Sorry, over there. So what will happen if we are performing here FCFS? So what will happen? P1 will execute first. It is but obvious. So first of all, we always go for the this queue. We will execute first this particular queue processes. Then we will give the priority of this one, then this one. But over there, if you have seen in the previous multi-level queue scheduling algorithm, these queues are not at all related to linked with each other, right? Like this. But here in this case, in the case of multi-level feedback queue scheduling algorithm, these queues are basically linked with each other. So what if P4 wants to execute it, and let's assume it's based on the scheduling algorithm which we are running, it gets the chance, but still we are not able to provide the CPU, then what will happen? Automatically P4 will go and come, right? P4 will come here. Then after that, oh, it is but obvious. If all the processes are executed, then they can execute it directly from there. So that's why we are also having this arrow over there. So you can directly map this particular multi-level feedback queue scheduling with our realistic, right? So yes, if anyone is having any doubt, just let me know. Yes, anyone? All right. So this is what we are doing it in the case of your multi-level feedback queue scheduling algorithm. So I hope this concept is clear to you, that exactly what we are doing it in the case of this particular scheduling algorithm. All right. So concept is quite simple. Here we are avoiding starvation because we are promoting, right? It's up to you whether you want to demote, whether you want to promote, right? So you can see that these are the time quantum. So a new job enters Q2, so which is served by FCFS. Then when it gains, job receives 8 millisecond. If it does not, so job is moved to Q1. So it's up to you basically how you are going to use it, right? So I'm not saying that this is the only way you can promote it. You can also demote it also. So promotion, demotion, all is possible, right? So here the main idea is like, just because of this promotion, demotion, just because of this feedback concept, we are never going to get the problem of starvation. So that is why in most of our modern operating system, we are using this multi-level feedback queue scheduling algorithm. But I'm not saying that, okay, we are exactly using it. Again, we are using some other concepts too. But the majority of main funda of using it in main funda, basically, we are using this particular. All right. So after that, you can see we have a lottery scheduling algorithm. So I hope now, if anyone is having any doubt, please unmute your mic. Otherwise, we are going to start with lottery scheduling algorithm. Yes, anyone having any doubt, anything? All right. Now we are going to discuss about lottery scheduling algorithm, and these algorithms are known as advanced scheduling algorithm. Why we are calling it as your advanced scheduling algorithm? Because these all other previous algorithms are like they are like before 2000, right? But even though I'm not saying that lottery scheduling is very new, even it was also like during the period of 1990s, but these algorithms are much more advanced in comparison to those algorithms which we have already studied, right? So in the case of lottery scheduling, what they are doing is like, you already know that we are choosing different criteria. Sometimes we are using least burst time, sometimes we are choosing or preempt on the basis of time quantum, arrival time, priorities, right? Like that. So in the case of lottery scheduling, so don't get matched with compare with multi-level queue. So in multi-level queue, we are using multiple queues, right? But here in the case of lottery scheduling, because this is just an idea, this is just a concept. So here in a single queue, if you are having a single queue, like in this queue, we can apply any scheduling algorithm. In a similar way, we can also apply lottery scheduling algorithm too. So the question is, sir, what we generally do in the case of lottery scheduling? So as the name suggests, lottery. So what terms comes first into your mind whenever we will think about lottery? That is somehow related to gambling. And being a computer science engineer, whenever you will heard about this term gambling, so first term that comes into your mind is probability. Right. So this is what we are doing it in the case of lottery scheduling. So we are using the concept of probability, and using probability, we are selecting the processes. Remember, in other scheduling algorithm, like on the basis of arrival time or least or time quantum, we are selecting the processes now. So here we are selecting the processes on the basis of probability. But the probability is decided by lottery. On the basis of lottery, we are deciding. So now Let us take one more example. All right. So again, we are accessing that same ATM machine. And in this ATM machine, remember here we are discussing about only single queue, right? So here we have P1 person, P2, P3, P4, P5, and P6. And let's assume P10, right? So what I will do is, instead of selecting the person the person who is going to access this particular ATM card, right? Sorry, access this ATM machine. What we can do is, otherwise we generally use arrival time, or either we are using burst time, right? Here in this case, what there is a security guard, right? So this security guard, what he has done is he give you can say that 10 lottery tickets, right? 10 numbers, 1 to 10, 1 to 10. What he has done is he gave 10 numbers to these persons. So automatically the P1 will get, let's assume P1, 1, 2, 3, and let's assume they will get the same numbers like that. All right. What happened? They will get these numbers right now. Now, what happened after that? In order to access this ATM machine, what they have done is the guard is now drawing the number, right? The ticket from some bowl. So you already have visited some, I have an idea about lottery, and pick up some ticket, right? So the guard has picked up some ticket, and in that particular number, the number is 2. So he will say, hey, 2. So the person who is having this lottery number 2, he will get a chance, and based on that, he is going to access this ATM machine. So in a similar fashion, in the case of our lottery scheduling algorithm, what we are doing is we are giving lottery tickets to our processes. And remember, we are not giving only a single lottery. All right. So if you already know about, like, if you have invested your money, all right, on lottery, so you have seen, like, and if you haven't, even though if you haven't invested, still you already know that sometimes whenever there is a lottery, let's assume there are two persons, right, P1 and P2, and there are 100 lotteries, right? So let's assume that this P1 person, by how many lotteries? Have taken 90 lottery tickets, and P2 have taken 10 lottery tickets. So if I will ask you, like, okay, can you tell me what is the probability that this P1, if I'm going to draw a ticket, all right, from a bowl of this 1 to 100 number, so which person will win? So you will say that there is a very high probability, that is 90 by 100. I'm not saying that there is a surety, right? We cannot comment on that. If there is a match between India and West Indies, what we say that we can never say that, okay, India will surely win. What we generally say that, okay, there is a very high probability, that is 70% or 80%, that India will win. So in a similar fashion, what we can do is, if there is high tickets that our person P1 is holding, so there is a very high probability that he will get a chance and he will win, right? This particular lottery system, right? So in a similar manner, what we are doing in the case of lottery scheduling algorithm is that every process has some ticket. So we are giving, right? So we are giving, right? Like, okay, for this particular process, we will give these number of tickets, right? Now the scheduler, over there we have a guard, here we have a scheduler which picks a random ticket. The process having the ticket wins it and execute it, right? Like this. So one thing which you can notice it over there is, like, the process which is having the higher number of tickets give it more chances of execution. So it is but obvious, if a person is having 170 tickets, right? So there is a very high probability that his or her number will come. I am not saying that he will surely win, even though it might be possible that a person who is having only a single ticket, and his or her probability is 1 by 100, still he or she is having a chance to win it, right? So we have already seen it, right? Like, there are many matches, cricket matches we have seen, like, okay, there are many teams, like, for example, if there is a matches among India and let's assume Bangladesh, all right, and suppose the winning percentage is 95 and suppose the Bangladesh is 5%. Still, let's assume in that particular match, in Bangladesh won that particular match. So we are not saying that okay, Bangladesh won't be able to win that particular match, right? But we are telling that the probability is less. So that is why this algorithm is really a very good algorithm. Why? Because even though if your probability is less, but it doesn't mean that you will not get a chance. So hence you will get a chance. So once you will get a chance, that what does it mean? It means that you will never get stuck in the issue of starvation. You will never get the starvation problem over here. So in order to understand this particular problem more clearly, so let's take this lottery scheduling question that suppose if we have two processes, PA and PP, they are in my ready queue, right? And let's assume I have given 30 lottery tickets, means the number from 1 to 30 to our this PA, and for from 31 to 100 to our PP, right? Now the scheduler will pick what? The scheduler will pick some a single lottery ticket, right? Some lottery ticket he or she will our scheduler will pick. So you already know that based on our probability, right? Because we already have studied this lottery, sorry, probability in our school time, or even in the first or second third semester, we have already studied what actually this probability is. So you can directly say that okay, sir, the probability of selecting a process PA is 30 by 100 and that is 70 by 100. So I'm not saying that okay, every time this process gets selected. No, it's not like that. And remember that lottery scheduling algorithm is using the concept of round robin, right? So in round robin is a combination of FCFS, and after that we have a time quantum, right? But in the case of lottery scheduling algorithm, what we are doing is we are using, instead of FCFS, we are using lottery scheduling. Means on the basis of lottery, we are selecting a process, and after that we have time quantum also. Otherwise, we will get stuck in starvation problem. Na? And in lottery scheduling algorithm, we are not getting any starvation issue. So that is why you can see over there the probability is what, 30% and 70%. Now let's take a random scenario. So what I have done is like whether this statement is correct or not. So what I have done is I have selected 10 random numbers, right? So you can say that I am getting 73, 82, these 10 numbers. So one thing which you can notice over there that whenever your number is in between 31 to 100, so B will win. Otherwise, 1 to 30, A will win. So you are getting B, B, A, B, B, something like that. So the question after drawing 10 tickets, right? So one thing which you can say that, okay, sir, based on it might be, this should be random, all right? So it's not like you will also get the same result. But for our result, what we have seen is like, okay, 2 times A is coming and 8 times B is coming. So, but over there, sir, you told me about that there is a 30% chance and the probability of selecting B is 70% chance. But here, after drawing 10 tickets, we are getting a 20 and 80. So whether it is correct or incorrect. So this thing is again correct. Why it is correct? Because we are always calculating probability not for a single numbers like for 10 or something like that. So if you will pick your numbers like between 10 to 1000, right? So then I'm not saying that exactly you will get it, but yeah, you will closer to that particular number. Automatically, when you will increase these numbers, so there is a very high probability that you will go through and you will get the number. You will get that particular number, right? So the advantage is that it solves the problem of starvation and we are giving the probability, right? Why we are not getting stuck in the problem of starvation? Because here we are getting non-zero probability of selecting, right? So I hope this concept is clear to you. So in the next lecture, we'll discuss about HRNN, and that is the last algorithm, scheduling algorithm. This is quite simple. It will hardly take 5 to 10 minutes of time. All right. But still, I hope now you are in a stage, you are able to understand that what starvation problem is and all those things. And what I'm advising you all to please try to create your own algorithm. If it is possible, try to create it. It will hardly take means 30 minutes or 40 minutes, right? But I want that you should try to create. I'm not saying that okay, we are going to use it in your operating system, but at least I just want to check like okay, on what criteria you are basically, you can choose your own criteria also, right? So you can directly, so those who have done it, I am advising you, right? Please post it either in your WhatsApp group, or either you can directly send me on MS Team, all right? Because I want from you guys to like okay, because you are, if you want to be a researcher, right? So you should have this particular this kind of practice, right? You just try to innovate some of the methods by your own, all right? So I want that all of you should do it. It's not a mandatory task, right? It's not, I'm not going to give you some marks for that, but not everything is for your marks, right? I just want to see like how innovative you are. It might be possible someone have proposed the same algorithm like you. I'm not saying like okay, go and browse other algorithms, scheduling algorithms, but I what I want is that just think about it. Just sit, just think about it like on what criteria I should select it, right? So there can be n number of criteria, right? Like here we have taken lottery system and all, so you can select any other system by your own. All right. So I hope in today's class, everything is clear to you related to scheduling algorithm and what a scheduling algorithm we are using it in our modern days computers, right? Like